Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at linear transformations. So I am going to show you how to find the inverse of a linear transformation and how to compose linear transformations. Alright, so let's begin with a basic example. Let's first of all start with composing linear transformations. So if you have a linear transformation, for example, defined from r squared to r squared, such that any point in r squared is mapped onto this point 2x plus y comma y. Okay, and maybe you have another transformation s for maybe r squared as well, right up till r squared, defined such that any point in r squared is mapped onto the point maybe x plus y comma y, and you are asked to find the composition of these two linear transformations. Maybe let us find t of s. Now t of s is actually the same as ask you to find t of s of xy, okay, which I can write this as t of s of xy. Now what is s of xy? S of xy is basically this point, so this is the same as finding t of the point x plus y and y. Now we know that actually t of xy is equal to 2x plus y and y. What does this mean? This means that t of x plus y and y will be equal to what? What I need to do is that I need to replace this x coordinate here with x plus y, and then the y coordinate remains as y because the y coordinate is y, but the x coordinate is x plus y. So this will give me 2 into, in the place of x I replace it with x plus y, then plus in the place of y I say replace it with y, since the y coordinate does not change, and then now the y coordinate also does not change, so we allow it as y. So if we simplify, we are going to have 2x plus 3y and y. So this is the transformation t of s. Alright, so as maybe as an assignment or as an exercise, find the transformation s of t and comment your answer in the comment section. Now let us now see how we can find the inverse of a transformation. Okay, so if I still give you a basic transformation that takes points in a plane to points in a plane, and I give you that it is maybe xy is mapped onto, I can say x plus y and maybe x minus y, for example. Okay, and I say find the inverse transformation. So the objective is to find t inverse, that is the inverse of t. That is the objective. All right. So how do we do this? The first thing is that I must bring out the matrix of transformation. So this transformation means that t of any point is equal to x plus y, x minus y. So to bring out the matrix of transformation, I just need to pick out the coefficients of x and y in every term, and I write it in order. So 1, 1, 1, negative 1. So that is the matrix of transformation we multiply by the point. You realize that if you actually carry out this matrix multiplication, you're going to have x plus y as the first entry and x minus y as the second entry. So this matrix here is what we call the matrix of transformation. So the inverse transformation, so in fact this means that the transformation itself of any point xy is just equal to the matrix of transformation times a point. So by definition, the inverse transformation of any point is equal to the inverse matrix times the point. Okay, so that gives us the inverse transformation. So in this case, I just need to find the inverse matrix. So if m is equal to 1, 1, 1, negative 1, it means that the determinant of m is equal to, you need to do the product of the elements in the leading diagonal minus the product of the elements in the non-leading diagonal. So it is 1 times negative 1 minus 1 times 1, which will give us minus 1 minus 1, which is minus 2. Okay, so it therefore means that the inverse, we know that it is 1 over the determinant, so 1 divided by minus 2 times the aggregate. How do we get the aggregate? The aggregate is basically since it's a 2 by 2 matrix, we have to interchange the elements in the leading diagonal. So we have -1 here and 1 here, and then we change the signs of the elements in the non-leading diagonal. So we have -1, -1. So if we want to factorize a half and we multiply every term by negative, we are going to have 1, 1, 1, -1. So that is the inverse matrix. It therefore means that the inverse transformation of any point is equal to the inverse matrix 1, 1, 1, -1 times the point. That gives you the inverse transformation. So see you guys in the next video. Okay, if you have any question, make sure you ask in the comment section. In the next video, I'm going to show you how to prove that it is a linear transformation and how to find the image of any figure under a given transformation.